All right, so in chemistry so far, we talked about solids at the beginning of the year. We've been working with liquids, right? Making solutions and things like that. And now we're going to end by talking about gases. So somewhere in your notes, take a second to copy down, I guess, the characteristics of gases. So gases, they move together, they move freely, and they're not bound together. Okay, so we got some pictures here kind of demonstrating that. Solids, molecules are fixed, they stay together. Liquids, they stay together, but they move around freely. Gases move freely, and the molecules are not bound together. Okay. So gas molecules, you can kind of just think about them as constantly like flying around everywhere. Okay. So that's gases. Okay, one thing about gases that I want you guys to write down, you guys don't need to write down all three, is this part right here. Gases, they expand to fill their container. So whatever container a gas is in, that's going to be the volume. So if you put a gas inside of a 1 liter container, the volume of the gas is going to be 1 liter. Okay, easy way to think about this. If you fart, right, in this classroom right now, your gas will expand to fill the container, which is the classroom. Okay, that's an easy way to remember that. Okay, gases expand to fill their container. And just a heads up, I'm going to be talking about fart a lot during this unit because that's what helped me remember a lot of gas law stuff. Okay. All right, any questions about the properties of gases that we talked about so far? It's pretty simple. You guys might have probably learned this in other science classes throughout the years. You can just write KMT.
Everyone go. Oh my God.
Okay. Sorry guys, we got my AP students in here, that's why. All right, so let's go over a couple of the things we'll be talking about and calculating for gases. The first property of gases you guys need to write down is pressure, and then we denote pressure with the symbol P. Okay. So pressure is denoted with the symbol P, and pressure is how hard the gas molecules basically bump into each other and into the objects that they come into contact with. And we measure them with these units of measurement right here, ATM and millimeters of mercury, mmHg. Okay. So pressure is P, and it's how hard the gas molecules bump into stuff. And we measure it with ATM, it stands for atmospheres, or mmHg, which is millimeters of mercury. Okay. No, it's okay. Is the desk okay? I'll fix it later. Thank you. Okay, so easy way to kind of think about pressure is, you guys know the higher up you go, there's less air, right? That's why people wear oxygen masks when they go to the top of Mount Everest and things like that. So here on this picture, I have the distance from sea level. So at sea level, and this is around where Long Beach is, the air pressure is around 1 atmosphere, okay? But then as we go higher and higher up, and on the top of Mount Everest, that the air pressure is around 0.326. So if you guys notice, where is there more air pressure? At Everest or Long Beach? Which one has more air pressure? Yeah, Long Beach. Look at the numbers. 1 versus 0.326, right? This number is bigger, so there is higher air pressure. So there's more gas molecules down here at sea level, and they also bump into things harder. So you guys are getting hit by air molecules right now, and you're getting hit by them harder than if you were at a top of a mountain. Okay, so the reason why is because there's more air down here at sea level. Okay, so that's pressure. Okay, let's move on to the next property. The next property is volume. We know that we denote that with V. Okay, and volume, we've talked about volume already. It's the amount of space a gas takes up. Okay, and we measure that either in milliliters or liters. So volume is how much space a gas takes up. It can also be the size of the container the gas is in. and we measure it in milliliters or liters. I didn't say anything. I am. All right, and then the third one is temperature. And temperature is how fast the gas molecules move. So the hotter you make it, the faster the gas molecules will move. And in this class, we measure it in something called Kelvin. Okay, I know that we don't typically use Kelvin in our everyday lives. So if you guys want, or actually you guys should, copy down these equations right here. We usually use Fahrenheit, and this first equation right here is how we turn Fahrenheit into Celsius. And then once we turn it into Celsius, we just add 273.15, and that's what makes it Kelvin. Okay. So just to repeat, temperature, how fast the gas molecules are moving. We have to measure it in Kelvin for this class. Okay, and then what we can do is we can take Fahrenheit. We can use this equation to turn it into Celsius. And then we just add 273.15, and that's what turns it into Kelvin. Okay, so we'll pause right there, and I'll have you guys try your first problem on your own. I want you guys to look up the weather today in Long Beach. It's a little cold. And I want you guys to convert the temperature that you guys find online, and I want you to turn it into Kelvin. Okay, so take about 2 minutes to do that, and then we'll move on to the last property of gases that we're going to talk about. Okay, guys, so it's 58 degrees Fahrenheit outside today. So first we're going to plug it into this equation right here. So we know that degrees Celsius is 0.56 times 58 minus 32. So on your calculator, you're first going to do 58 minus 32 because you got to do the parentheses first. So all you got to do for the last step is 0.56 times 26. We're just going to multiply that with 0.56. So your Celsius is going to be 14.56. Okay, so right now it is 14.56 degrees Celsius outside. And then in order to turn it into Kelvin, we just add 273.15. So we just go on our calculator and add 273.15, and that'll give us 287.71. Okay, so 287.71 Kelvin. Yeah, so let's go through the steps one more time. So first thing you want to do is inside the parentheses, 58 minus 32. So 58 minus 32. That's how we get 26 right here. And then we do 26 times 0.56. That's how we get 14.56. And then we just add 273.15. Okay. All right, any questions on how we calculated that? Okay. All right, so just make sure that you are comfortable using these equations, because for this entire unit, whenever we talk about temperature, you have to turn it into Kelvin or none of the equations will work. Okay. I don't know why they make it so complicated and have 3 different units of measurement for temperature. Let's just keep one. Just do Kelvin. Okay, let's move on to the last property of gases that we're going to talk about for this unit. And the last one's super easy. It's just moles. Okay, and then we denote moles with the symbol N. Okay, and moles is how many moles of gas there are, so how much gas there is. And usually we're going to get it in grams or something like that, and you just need to convert grams to moles using molar mass. Okay, so this is probably the easiest one. Okay, so I'll give you guys about 2 minutes again. I want you guys to finish up this problem right here. If you have 12 grams of oxygen gas, the formula is O2. How many moles of O2 do you have? This should be a very simple question. We've been doing this since like September, I think. So take about 2 minutes to do this. Very good question. Oh, it's okay. That's why you're going to calculate it. So again, just take the 12 grams and turn it into moles using molar mass. Okay, I'll give you guys about 2 minutes to try it, and then we'll go over it together. So what we're going to do is, first thing we're going to do is we're going to write down 12 grams, and the chemical we're looking at is O2. All right, so if we take a look at the periodic table to find the molar mass of O2, we're going to look at oxygen because O2 is made out of oxygen, right? There's 2 oxygens inside of O2. So we're just going to have to add this twice. So 16 plus 16. Okay, so that means that the molar mass of oxygen is 32 grams in 1 mole. Oh, thanks so much. Okay. I appreciate you guys too. Thank you. All right, so this is how we set it up. Since we have grams and we want to get rid of it, we put grams on the bottom. And since we want to turn it into moles, we put moles on the top. Okay, so from here, the math is really easy. It's just top divided by bottom. So all you got to do is 12 divided by 32. And so your final answer will be 0.375 moles of O2. Okay. So whenever you're turning grams to moles, just divide it by the molar mass. Super simple.
Appreciating and celebrating you.
No, I'm good.
I think we need a thing for you.
No, I'm good.
I think we should put your picture up on the screen.
Quiet. I know. Alrighty, guys. Any questions on the properties of gases? Okay. So when we put all that together, okay, the thing that we're going to be talking about mostly throughout the unit is something called gas laws. Okay, because when you change one property of a gas, some of the other properties are going to change with it. Okay, so we're going to talk about the first gas law today. Okay, I'm going to give you guys the equation. We're going to do a couple problems, super easy, and then I'll have you guys practice on your own. Okay, so today we're going to be talking about the first gas law, and it's called Boyle's law. Okay. Okay, and Boyle is the dude who came up with this gas law. Okay, guys, you guys are a little too rowdy for a Monday. Where's all this energy coming from? I know, but you got those hooligans back there. Oh my goodness. Okay, guys, so the first gas law is Boyle's law, and Boyle's law basically means in Boyle's law, it tells us that if the pressure of a gas goes up, the volume goes down. So if you increase the pressure, the gas will get smaller. Okay, make sure you guys are copying this down. And the equation that we use to solve these problems is this right here. P1V1 equals P2V2. Okay, so that's the only equation you're going to be using today. And then I'll show you guys how we can use that equation. Okay. Okay, but Boyle's law is basically the reason why if you guys have a balloon and you let it go outside, it goes up and up and up and up, and then it's going to pop eventually. Okay, it's because there's less pressure, so the balloon gets bigger to the point where it just blows up. So, yes. So pressure, the first pressure and the original volume equals the new pressure and the new volume. You're multiplying these. These are being multiplied. I'll show you how to, we'll do a problem where I'll show you guys how to use the equation, so don't fret too much. But let me show you guys how Boyle's law looks in real life. So here I have a container, and I got balloons inside of it, right? So there's gases inside the balloons, right? So there's a pressure inside the balloon, and then there's air in the jar around the balloons, right? So there's air inside the jar that's pushing down on these balloons, and that's why they're the size that they are. This is the volume, the V, okay? Okay, but what I'm going to do is I'm going to use this little vacuum thing, and I'm going to take out the air from inside of the jar. So if I take out air, what's going to happen to the pressure? Is it going to go up or is it going to go down? It's going to go down. So if the pressure goes down in here, you think the volume of the balloons is going to get bigger or smaller? Yeah, bigger. It's going to be the opposite. So I'm going to take out the air and let's see if the balloons get bigger. Okay. What we're doing is we're taking out the air. Yeah, they're getting claustrophobic now, right? Really weird, right? Yeah, so I'm taking out the air, so the pressure is going down inside the container. And as you guys can see, the balloons got a lot bigger, right? And then the opposite is true too. If I put air back in by releasing the valve, the balloons should get smaller. And so that's basically what Boyle's law tells us. You get rid of the pressure. If you change the pressure one way, the volume goes the opposite way. Okay? So that's basically what we did right here. Okay, so enough of that. Let's do one calculation problem, and then I'll get you guys started on your assignment. So P1 V1 is P2 V2. This is the equation that we're going to use. Okay? Easiest way to think about this is the ones is the original, and the twos, original, and then the twos are the new. Yeah. Go in the balloon. You put your mouth on the balloon. Oh, there's a little valve right here. So when it's like this, it's closed. But when I take it off, the air can go back into the valve. Was that your? How do balloons get bigger? You put your mouth on it.
Yeah, wait, and then how does it just get smaller? Like,
Oh, yeah, so this is the valve, right? And this vacuum can take out air from inside of the valve. Am I answering your question? Because like 4 people are asking your question for you.
No, wait.
The air, because the balloons have air in them too, right? And so they're this shape because the air inside of balloons there's pressure in the balloons, right? Pushing the balloon walls. And then they're this shape because it's kind of like a balance between the air in here pushing against the balloon and air out here pushing into the balloon, right? So if you get rid of the air pushing out or pushing in, the balloon can just get bigger. Yeah. Yeah. Thank you. It's very difficult to understand you guys when 4 people are asking different questions. It's okay. Hey, Diego, you need to make new friends, man. Those hooligans back there. All right. So anyway, P1, the P1 and V1, think of it as the original pressure and the original volume. And P2 and V2, think about that as the new pressure and the new volume. So when you guys are doing these gas laws, you want to look at the numbers and figure out, is this number P1, V1, P2, or V2, okay? So let's take a look at this. So it says a balloon occupies 1.5 liters at a pressure of 25 mmHg. What is the volume of the balloon when the pressure is increased? Okay, so what we're going to do is we're going to go through all of these numbers and figure out which one of these they are, okay? So let's take a look at 1.5. Okay, first of all, is it P or V? V, yeah, volume. 1 liters is going to be volume. Okay, now is this talking about the original volume or the new volume? Yeah, original, so it's going to be V1. Okay, so this is what you want to do as you go through the problems because it matters what side of the equation you put the numbers on. Okay, and that tells you that it's pressure of 25. So this is going to be pressure. Is this talking about the original pressure or the new pressure? Original, yeah, this is both original. And then it's asking us to find the volume. So it's asking us to find V. We're looking for V, and obviously this is V1. So we're looking for V2. And then the pressure is increased to 95. So this is going to be P2 because this is the new pressure. So what we did is we just basically identified which variable are all of these numbers, okay? So I'm going to give you guys 2 minutes, see if you guys can plug it into the equation and get the correct final answer. Make sure you try to get the unit of measurement as well, okay? So is it at the very end, is it milliliters, liters? Yes. No, not this time. Okay, so all we got to do is just plug in these numbers into this equation right here, okay? So P1 is 25, so 25 millimeters of mercury. That's going to be P1. V1 is 1.5 liters, so 1.5 liters is equal to P2. Oh, wait, sorry, we know P2 already. P2 is 95, so 95 millimeters of mercury. And we're looking for V2. So this is going to be the equation that we're working with right here. Yes. Yeah, you have to take care of this 95 as well. You do. Yeah. So, all right, guys. So we gotta move this 95 to the other side so that V2 can be by itself. If you guys notice, these two are being multiplied, right? So how can we move 95 to the other side? Yeah, we divide both sides by 95. So if we divide both sides by 95, we get this right here. Okay, so we got V2 is equal to this equation right here. But super simple. All we got to do is multiply the numbers on the top. So we got 25 times 1.5. And then we divide that by 95. So the new volume is going to be 0.39. Okay, so V2 is going to be 0.39 liters. Okay, and that makes sense because if you take a look at the problem, the pressure goes up, right? It goes from 25 to 95. So if the pressure goes up, that means the volume should go down. So it goes from 1.5 to 0.39.